Hello students, welcome to EDUHUNT online video classes. In the previous session, we have discussed the concept of area of triangle. We have found different areas of different triangles. In this session, we are going to see areas of some quadrilaterals. Okay, let's see area of a quadrilateral. A quadrilateral means a four-sided closed figure, that is called quadrilateral. Here, this is a quadrilateral ABCD. We have to find the area of this quadrilateral. I can divide this quadrilateral into two equal triangles or two different triangles. This is the perpendicular or height, this is the perpendicular or height. This is E and this is F. Area of quadrilateral equal to area of triangle ADC plus area of triangle ABC. Already we have seen area of triangle is half into base into height. Area of triangle ADC half into base is AC into height is DE plus area of triangle ABC. Again this is AC half into AC into BF. So I can take half and AC both common. Half AC into DE plus BF. Half into AC is nothing but diagonal. D into DE and BF are perpendiculars or heights. So I can write H1 plus H2. This is the area of a quadrilateral. If I take the parallelogram area, this is a parallelogram ABCD. In this parallelogram, AB is base and CD is base. This is perpendicular height, this is also perpendicular height. So area of triangle ABD, this area plus this area is area of parallelogram. So this area is half into AB into DE, half into CD into BF. Okay, here half into base into height, again half into base into height, half BH plus half BH. Okay, so area of a parallelogram is base into height. Now let's see when a diagonal and two adjacent sides of a parallelogram are given. This is a parallelogram. In this parallelogram, two adjacent sides AD and CD are given, that is A and B. Diagonal D is given. So this is a triangle. Already we have discussed in the previous classes that if three sides of a triangle are given, then we can use Heron's formula. So that is to find the area of a triangle, we can use this formula S into S minus A into S minus B into S minus C. Here S is equal to semi-perimeter A, B, D. So A plus B plus D by 2. S is semi-perimeter, that is A plus B plus D by 2. So I can substitute square root S into S minus A into S minus B into S minus D. Here two equal triangles are there. This is one triangle and this is another triangle. So I can take area of this quadrilateral equal to 2 into square root S into S minus A into S minus B into S minus D, where S is semi-perimeter A plus B plus D by 2. This is the area of a parallelogram when two adjacent sides and one diagonal is given. Already we have discussed at the first, area of a parallelogram is equal to half into diagonal into perpendicular, sum of perpendicular heights, that is H1 plus H2 or P1 plus P2. This is the diagram. Let's see the definition first. A parallelogram whose all sides are equal is called rhombus, and its diagonals bisect each other at right angles. This is a rhombus. All these four sides are equal and diagonals bisect each other at right angles. That means here it is 90 degrees, here it is 90 degrees, here it is 90 degrees, and here it is 90 degrees. Okay. Now let's see, I can find the area of this rhombus by taking areas of two triangles, that is ABC and ADC. So area of rhombus equal to area of triangle ABC plus area of triangle ADC. Area of triangle ABC is half into base is AC, height is OB, plus half into base is again AC into OD is height. Here we can take half AC common. This is OB plus OD. Half into AC into OB plus OD. OB plus OD is BD. Half into AC is one diagonal and BD is another diagonal. So we can take half into D1 into D2. Half into diagonal 1 into diagonal 2, that is area of rhombus. Now let's see the area of a trapezium. First of all, we should know what is a trapezium. It is a quadrilateral in which one pair of sides are parallel. That is, these two sides are parallel. Let it be ABCD. This is A, this is B. So, distance between these two parallel sides is H. So, area of a trapezium is equal to half H into A plus B. Here H is height or distance between two parallel sides and AB are measurements of parallel sides. One is A and another is B. Okay. This is the area of a trapezium. Based on this concept, let's solve few examples. Find the area of a quadrilateral ABCD in which BP and DQ are perpendiculars drawn to AC, in which AC is equal to 20 cm, BP is equal to 8 cm and DQ equal to 6 cm. Here we have to find the area of a quadrilateral ABCD. This is quadrilateral ABCD. AC is 20. This is 20 and BP is 8. BP is perpendicular drawn to AC. This is 8. DQ is 6. So, area of quadrilateral is equal to half into diagonal into sum of perpendicular heights H1 plus H2. So, that is half into D is 20, H1 plus 8, H2, 6 plus 8, 2 ones, 2 tens, half 10 into 14, that is 140 centimeter square is the area of this quadrilateral. If the diagonals AC and BD of a quadrilateral are perpendicular to each other, AC equal to 24 and BD equal to 40, then find the area of the quadrilateral. Area of the quadrilateral is equal to half into diagonal into H1 plus H2. This is the area. Half into, here two diagonals are given and the condition is also given. Here AC and BD of a quadrilateral are perpendicular to each other. Perpendicular to each other means I have to find the areas of two triangles. This is one height and this is another height because these two are perpendicular heights. The sum of those two perpendicular heights is 40. So, this is 40. So, diagonal is 24. 2 ones, 2 20s. So, 20 into 24. 2 4s 8, 2 2s 4. 480 centimeter square is the area of this quadrilateral. Okay. Find the area of a parallelogram ABCD of a side 20 centimeter and height is 12 centimeter. So let's draw the parallelogram ABCD. So this is 20 centimeter and height is 12 centimeter. So area is equal to base into height. Base is 20 and height is 12. So 12 into 2. 2 12s 24. 240 centimeter square is the area of this parallelogram. Find the area of a parallelogram ABCD in which AB equal to 20 centimeter, BC equal to 15 centimeter. If the corresponding height on AB is 6 centimeter, what is the corresponding height on BC? First thing, we have to draw the parallelogram ABCD. AB is 20, okay, and BC is 15. If the corresponding height on AB is 6, this corresponding height is 6, then what is the corresponding height on BC? So this one we have to find corresponding height. So to find this corresponding height, first of all we have to find the area of this parallelogram by using this base and height. Then that is equal to area of this same parallelogram with base 15 and height this one. Okay, right. So area of parallelogram is equal to base into height. Base is 20 into height 6. Okay, right. Now this area is equal to same area by using different measurements. Base is 15 and corresponding height is DE. So base is 15 into DE. 5 3s, 5 4s, 3 1s, 3 2s. So the DE is equal to 2 4s, 8 centimeter. So that corresponding height itself is 8 centimeter. Okay, right. Find the area of a rhombus if the diagonals are 24 centimeter and 30 centimeter. This is a rhombus. This is one diagonal and this is another diagonal. This is 30 and this is 24. So area of rhombus is equal to half into D1 into D2. Half into D1 24 into D2 30. 2 1s, 2 12s. So 12 into 3 36, 360 centimeter square is the area of this rhombus. Find the area of a trapezium if parallel sides are 16 centimeter and 24 centimeter and distance between the parallel sides is 12 centimeter. This is a trapezium. These are parallel sides. This is 16 centimeter and this is 24 centimeter and distance between the parallel sides is 12. So area of a trapezium is equal to half h into a plus b. H is distance between two parallel sides, so that is 12, and a plus b, a is 16 and b is 24. So 24 plus 16 is 40, half into 12 into 40. 2 1s, 2 20s, 12 2s 24, 240 centimeter square is the area of this trapezium. Now let's see some facts. Area of a square is side into side. This is a square, a quadrilateral in which all sides are equal. Basically it is called square. So side into side, so we can write this is a side square. Otherwise if I take side A, then we can write A square. Rectangle, in a quadrilateral two opposite sides are equal. So this is length and this is breadth. L into B is the area of this rectangle. In a square, diagonal is given. diagonals are equal and perpendicular to each. In a square, diagonals are equal and perpendicular to each other. So this is D. If only diagonal is given, D square by 2 is the area of that square. In this session, we have discussed the areas of different quadrilaterals. Okay. Thank you for watching.